Okay, so now we're going to look at how to do a paired t-test. Before we do that, let's contrast the data sets that we have. Okay, so first of all, I'm going to open the old data set, which is Lichen 1. I'm actually going to give it a name this time, so let's remove data set and call it Lichen 1 so we can look at it. Remember, it's comma separated values, and it's the CSV file Lichen 1. Okay, we open that, we can view that data. Okay, remember that what we had in that data was a number of trees, and some of the trees were, the north face was measured, we got a lichen content measurement for that side, and for some of the trees the south face was measured, we got lichen content for that. Okay, now in the paired example, each tree is measured twice, so we can import that data set. I'm going to call that Lichen 2. Comma separated values again. It's called lichen2.csv. We'll just open that data set. Let's view that data set. So here we can actually look at both data sets side by side. Again, there's 40 measurements for both data sets, but this one has for each tree a north and south measurement, whereas this one has for each tree either a north or a south measurement. Okay, so there's a very different structure in the data, and these are what's called paired observations. Okay, so to do a paired t-test, again, we're going to statistics, means menu, and here you see underneath independent samples we see paired samples. Okay, this is because I loaded in Lichen 2 last, so it's my active data set, and there's nothing in there that enables me to do an independent samples t-test on Lichen 2, so it has to be paired. So independent samples is actually grayed out. Click on paired, which order we want to do things in. So we're going to do Lichen North and Lichen South as the second variable. So this is consistent with the way it was done in lectures. You could do it the other way around, of course. Okay, we're then going to look at the options. Here we have, again, a level of confidence for a confidence interval. This is going to be based on the differences between the observations, again, and the alternate hypothesis. Let's leave that as two-sided. Just click OK. And here we get the measurements in blue. Again, the output in blue, it says paired t-test. It says the data is Lichen 2 $, Lichen North, and Lichen 2 $, Lichen South. It's got the t statistic, which was minus 81.8601, similar to lectures. The degrees of freedom is 19 because that's the number of pairs minus 1, and a p-value, which is essentially 0. It's less than 2.2 times 10 to the minus 16. Okay, it tells me that the alternate hypothesis was that the true difference in means is not equal to 0, and it has a confidence interval there for the true difference. Okay, and right at the bottom it says the mean of the differences was minus 22.3. Alright, we could look at the single-sided alternatives. Okay, we go to means, paired t-test again. They're still highlighted. Now we want to look at the alternate. The difference is less than 0. Click OK. We get basically the same results. The p-value here should be half what it was before, but it was so small anyway that it doesn't make any difference. Okay, and it tells me now that the true difference in means is less than 0 is the alternate hypothesis, alternative hypothesis. Okay, and let's look at the last one. The true difference in means is greater than 0. Now, of course, here in the data, we know that the true difference in means is actually less than 0, so it's unlikely to be any evidence that the true difference in means is greater than 0. Okay, so there the p-value is 1. There's no evidence at all that that alternate hypothesis is true. Okay, so that's paired samples.